right, guys, and for our last page of our notes with our factoring review, we're going to talk about factoring special products. And so there are two kind of special products that you can factor, and that would be your perfect square trinomial, and that is when you have a trinomial, which means that you have three terms here, whose factored form is a square of a binomial. So there's two different forms where if the factored form is a plus b squared, then the first term is your a squared. Your last term is your b squared. And then this middle term is 2 times the first term times the last term. And then this is the difference right here when it's a minus b squared. And the only difference here with this is where if you have a squared is your first term, right? A, take the square root of that. Your b squared is the square root of that is your second term. And then your middle term is -2 times your first term and your last term. Okay, so we're going to look at those. And then there's also a difference of 2 squares. And when we do our difference of 2 squares here, we can look at this and we can say, oh, well, a squared minus b squared. That's when you look here and you say, oh, you have 2 perfect squares. And that can be written with binomials where it's a plus b or a minus b. So we're going to take a look at these and we're going to see how to do this. So when we look at this, in this particular problem, we notice that this is a difference of 2 squares because this first term is a perfect square and our last term is a perfect square. So I'm going to do this in 2 different colors so we can kind of see it here. So we see, look, this is, so we take our 49x squared, and if I take the square root of that, then that would be equal to 7x. And then if I take, let's look at this guy right here, if I take the square root of 100, that would be 10. So we can follow our formula where it would be 7x plus 10 times 7x minus 10. So we can follow our lovely little formula right here. Sorry about the opposite colors on the ends. That kind of drives me crazy. So I'll try not to do that. But so we have plus 10 and minus 10. So this right here would be our difference of 2 squares, if we can take a look at that. So the simplified form is that 49x squared minus 100, and our factored form is that 7x plus 10 and the 7x minus 10. All right, now we're going to go over here to number 14. So this particular one, this is a trinomial, okay? So I think it was a little bit off on a couple people's things, but that is supposed to say minus 80. So we'll look here and we'll say, okay, now the reason we know that this is a perfect square trinomial is we're going to take a look at this in just a second. Okay, so we look at our first term, and that's what, 64x squared, and we're going to take the square of that. And 64x squared, the square root of that would just be our 8x, okay? And then we look at our last term, which is this 25. Take the square root of 25, and that is also a good number. But now we need to make sure that our a times our b gives us our c, or gives us that 2ab right there. So what we have to do is we have to look here and we say, okay, so it's going to be 2, because we got this little 2ab going on. We know we have a minus sign, so we're going to be a minus. So we have -2, and then times your a, which is 8x, and times your b, which is 5, and that equals, let's see here, what does that equal to? -2 times 8 is -16, and that gives you -80x, which is that -80x. So this fits that perfect square trinomial. Sorry, I was a little crooked there. So that fits the perfect square trinomial. So we can go ahead and we can write this guy. I'm going to do it here. Do it in a squared form, and this becomes 8x minus 5. All right, and it's squared, 8x minus 5 squared. So we can write this out as 64x squared minus 80x plus 25, and that is equal to 8x minus 5 squared. Because a squared would be 64x squared, b squared would be positive 25, and then a times b times negative 2 would give you that negative 80. All right, so now let's take a look at these last two. Now these are a little interesting because we need to make sure that we can take out our GCF here. So I'm going to see, we can take out 5, 20, 20, oh, we can actually take a 5 out of this. So we can rewrite this as 5x squared plus 4x plus 4, because I took a 5 out of each of those. So now we're going to take a look at this, and once we see this, we see that this guy right here hopefully will be a perfect square trinomial, because we notice that our first term, this x squared, that's a perfect square, and our last term is a perfect square. So we just need to check and see if that middle term fits the 2ab. So let's take the square root of x squared. That gives us x. So that is my a value. We take the square root of 4, and that gives us 2. That is my b value. We have a plus sign here. So we want to say, all right, positive 2 times a times b is going to give us, let's see here, that would be 4x. And that matches what we have in the middle. So this fits with our perfect square trinomial. All right? So we can rewrite this guy as, let's see, I'm going to do it in a parenthesis. So it would be x, that's our a value, and I'm going to say plus 2, because we have a plus sign right there, and that would be squared. But we can't forget our GCF that we took out at the very beginning to make that 5. We can't forget that GCF right there, right? Because this is our GCF. There we go. Sorry about that. So we would write this, so our factored form is this 5x plus 2 squared. Our simplified form is that very first one they gave us, that 5x squared plus 20x plus 20. So don't forget, you always need to check to see if there's a GCF. So let's check and see if there's a GCF on this guy. So we have 4x squared minus 36. So I'm going to see, is there anything we can take out? Yes, we can take a 4 out. So that just becomes x squared minus 9, right? And so that 4 is right here. So don't forget that that right there is your GCF. On these other ones, there was no GCF, okay? So that 4 is your, so now we're going to look at this and we say, oh, well, that would just be the difference of 2 squares, because x squared is a perfect square and negative 9 is, or 9 is a perfect square. So we look here and we say, okay, well, the square root of my first term is x. The square root of my last term is going to be 3. So if I was going to write this out, we would say, ooh, I'm going to do it in pink. We're going to have a plus and we're going to have a minus. So this becomes x plus 3 and x minus 3. I don't like that little dot there. X minus 3. So that's x plus 3 and x minus 3. And we can't forget about our GCF that we got up here at the beginning. So our factored form is 4, x plus 3, x minus 3. Our simplified form was this very first form they gave us here, this 4x squared minus 36. So guys, these right here are quick ways to recognize these special cases. Now here's the deal. If you can't recognize that this is a perfect square trinomial, or that this would be the difference of 2 squares, or vice versa, you can still factor it completely like normal, and you will still get the right answer for all of these. But knowing and memorizing these formulas is really helpful for you to factor a little bit quicker. And these formulas are also going to be available for you on like any reference charts or anything like that that you get on like the STAR test or anything like that. So I hope this helped you kind of recognize some of those special cases and when we can use that perfect square trinomial or that difference of two squares. All right, thank you very much, and I hope you all have a great day.